Welcome to Byte Sized AI, keeping you relevant in an AI world. I'm your host, Michael. Today we're diving into a hot new technology that's been blowing up. TurboQuant from Google Research. It promises massive compression for AI models with zero accuracy loss. Joining me is Randy, our AI expert. Randy, what exactly is TurboQuant and why should regular folks care about it?
Hey Michael, great to be here. TurboQuant is a smart new way to compress the working memory that large language models use while they're thinking, called the KB cache. Think of it like this. When you chat with a big AI, it has to remember everything you've said so far. That memory is stored as huge lists of numbers, vectors. Normally those take up tons of space. TurboQuant shrinks them dramatically, down to about 3 bits per number instead of 16 or 32, giving roughly 6x less memory usage. And it does this without hurting the model's answers at all.
6x less memory? That sounds huge, but I've heard people say it's just polar coordinates. Is it really that simple?
Not quite. The real magic is simpler and smarter than that. LLM vectors often have one huge number and lots of tiny ones, like a spotlight on one spot. You just chop precision on that, the vector basically snaps to a single direction and loses all the subtle information. TurboQuant's key trick, before compressing, it randomly rotates the vector in its high dimensional space. This spreads the energy evenly across all dimensions. Now when you reduce precision, you don't lose the important details, you just lose a bit of sharpness. Then you rotate it back when you need to use it. On top of that, they add a clever second step using something called QJL to make sure the math for attention, the dot products, stays accurate.
Got it. Rotate to spread things out, quantize, rotate back. Why does this matter for the hardware we run AI on?
Because memory is one of the biggest bottlenecks today. The KB cache grows with context length. Longer conversations or documents eat up GPU memory fast. With TurboQuant, you can fit 6x longer context on the same GPU, or run bigger models, or serve more users at once. On NVIDIA H100 GPUs, they're seeing up to 8x faster attention calculations too, because the data moves around much quicker when it's smaller. No retraining needed, works on existing models, and is fast to apply.
So does this mean we'll need less powerful or cheaper hardware in the future?
It definitely lowers the bar. Smaller companies and even enthusiasts with consumer GPUs will be able to run much longer context AI locally. In data centers, it means higher throughput and lower power bills. Some analysts even think it could shift demand. We might buy memory differently, but we'll probably just use the savings to run even more ambitious AI applications. Bottom line, TurboQuant makes AI more efficient and more accessible right now.
Fascinating stuff. Randy, thanks for breaking it down so clearly. Listeners, if you want the deep dive, check the Google Research blog and the RxIve paper. That's it for this bite-sized episode. Stay curious, stay relevant. I'm Michael. See you next time.